طيب بسم الله الرحمن الرحيم. So we'll continue the discussion regarding IP version 6. We have discussed the rules for abbreviating IP address version 6 last time. So we said that there are two simple rules. The first one is omitting leading zeros in each hextet separately, right? So we take each hextet separately, and then any zeros on the left-hand side we omit. The second rule is simply to replace consecutive zero hextets with double columns. So we can replace those leading or those repeated zero hextets with double column. And we are allowed to do this only once in the IP address. So we cannot use it twice. And the reason is that if you try to do it twice, you will not be able to get back the original IP address. If you try it, you will never be able to get back or to retrieve the original IP address version 6. So this is the rules to abbreviate the IP address. Based on that, we will see that in the next slides, we will see that the IP address becomes really small and short, and then it simplifies how to deal with this address later on. The second part of this lecture is to talk about the categorization of IP address version 6. In IP address version 4, we talked about 3 ways of categorization. The first one is based on the communication mode. So we said that we can have IP address version 4 to refer to unicast, or to refer to multicast, or to refer to broadcast. The second way of categorization is whether this address is a private address or a public address. And private address is used together with NAT to allow the router to translate the address to a public address, and in this way the private address becomes routable over the internet. The third way of categorization was the special addresses. Of course, private and public does not exist in the case of IP address version 6, because we don't need really to use private addresses and reuse these addresses, because the domain of the addresses now is available. So this way of categorization does not exist in IP address version 6. The third way of categorization is the special addresses, and similar again to IP address version 4, IP address version 6 also defines loopback address, defines link local address, and other types as well, which we will talk about when we get to that. Okay, so those are the two types of categorization for IP address version 6. So the special addresses, and based on communication mode, whether it's unicast or multicast. IP address version 6 does not have broadcast, right? Instead, it has something called Unicast. So Unicast is slightly different from multicast. So again, Unicast refers, you have one address that refers to a group of nodes. However, when you send address to the group, when you send a packet to the group, you don't send to the entire group. You send to any one of them, based on certain criteria. It could be that this one is the closest to you, and the router will have to handle this. So when you send a packet with an address in the range of any cast, then the router will say, okay, I have this group of nodes that belong to this group, similar to multicast, but I don't have to send the packet to all of them. I will send it to whichever one is closer. Okay? So it has to figure out the unique address of each node in the group, and then based on the routing table, it figures out that this one is the nearest, so I will send it only to this one. But again, Unicast is not in the scope of the course, so we will not talk about it in details. But it's just enough for you to remember that Unicast is similar to multicast, except that you send to one node in the group based on certain criteria, as opposed to sending to all nodes in the group. Okay. So having said that, so we'll go through this activity, and we'll try to extract or we will try to convert the full hexadecimal notation of the IP address version 6, and we try to shorten that and use the two simple rules to come up with the short version of this IP address. And later on, we will talk about the different types of IP address version 6, which is slightly more complicated than IP address version 4. So we'll talk about the details of this next. Okay. So that's so using these two simple rules, we can shorten the IP address version 6 quite a bit, as we can see. Okay. So that activity is trivial. So we will talk about multicast later on, probably next time. And there are two types of multicast, which we will talk about. There is solicited multicast and assigned multicast. So putting this aside, we have the special addresses for IP address version 6. And originally, there are 6 different ranges or 6 different types of IP address version 6. However, we will not talk about this one at all. So this is out of the scope. So embedded IP address version 4, this is totally out. So these 5, they represent different types of IP address version 6. So the first one is what we call the global unicast. For global unicast, this is the unique unicast that a node or an interface on the router can take, and it's routable all over the internet, which means that if you have a packet with an address in this range, the router will have to route this packet. Will have to send it over the internet. Okay? The link local address is similar to link local address in the case of IP address version 4. If you have a network and you have multiple nodes, okay, the link local address gets assigned to the interface and each of these nodes. And there are slight differences to the link address in the case of IP address version 4. The slight difference is that the link local address, of course, the domain for it is the local network, which means that if you have a link local address either in the source or the destination of the packet, the router will not pass this packet over the local network. Okay? So this is the local router. So the local router will not pass it through. Okay? If the link local address either in the source or the destination. Yeah, don't try to trick the router and put the destination address in the link local, but the source address, the destination is global unique unicast, but the source is link local. Then the packet will be discarded as well. Okay? The slight difference here is that for IP address version 6, the router by default automatically assigns a link local address to the interface of the network. And all the nodes will have by default link local address assigned. And they use that to communicate internally in the local network. But again, they cannot communicate to the internet using this link local. Okay?
What do you mean by the interface of the network?
The interface of the router that belongs to this network. So the router assigns a link local address to the interface, and this will be the definition of the subnet address that belongs to the link local interface, the link local of the entire network. So these nodes, as we will learn later on, these nodes will now assign to themselves a link local address in the range of the IP address of the interface of them, because the interface belongs to the same subnet of all these nodes, right? They all belong to the same subnet. So when you assign a specific link local address to the interface, all the nodes will be assigned link local address in this range, within this subnet. Okay? But again, this is for IP address version 6, a link refers to a local network. A link refers to a local network. طبعا loop back is fine. We know loop back, right? But remember that here it's one address. It's not a range of addresses like in the case of IP address version 4. When we say /128, this means that all the 128 bits, they have to match, which means that you have only one single address. There is the unspecified address. The unspecified address is all zeros, and it can be used only as a source address. It cannot be used as a destination. Because unspecified means that it's coming from anonymous nodes. And that may happen in two cases. One case is that a node may not have a permanent IP address yet. Okay? Yet it wants to communicate with some other nodes, either in the local network or outside. So in that case, it may actually use the unspecified address in the source when it sends the packet. Okay? But of course, it cannot use it in the destination, because in the destination means that it will go nowhere. So this is the unspecified. The other case is when the source is irrelevant to the destination. Yani the destination doesn't need to know where the packet is coming from. In that case, don't ask for reliable communication, right? Because if the source is unspecified, I cannot send any acknowledgement back. I cannot send any reply back. It's just one notification to the destination, and the destination will not be able to send back any reply or acknowledgement or anything.
Doctor, if the source doesn't receive a reply, does it keep sending until it receives one?
No, of course not, because it knows that it's specified, or it actually put unspecified address in the source. So in that case, it will not wait for a reply, because the reply will never come. Okay? So the last one is unique local, and I need you to pay attention to the difference between the unique local and link local. Again, link refers to a local network. Unique local here, the main difference between this one and this one is the range or the boundary. So the unique local address does not necessarily cover one link or a local network. It can be valid within an organization. So multiple local networks may actually use this unique local address to communicate within an organization like UU that has multiple local networks. This is the closest category to the private address. So for private address, you can use it within a house or within an organization, but then the termination router of this organization has to convert that to public. For unique local, it's not converted to public. Okay? So here you can so this router, so this is for link local. For unique local, the packet may go through in that case. However, when it goes to the ISP router, the ISP router will have to block it. Okay, so the unique local can go or pass through one local network, but the termination router of the entire organization will have to block it. So you can use the unique local to communicate not only within a local network, but within multiple networks. But all of them belong to the same location or the same organization. Okay? And then the termination router of that organization has to block any packet with this address range to go beyond the organization. Okay? So if a packet, either in the source or the destination, goes to the ISP router in this range, the ISP router will discard it. will block it. Okay? So the main differences between unique local and linked local is that unique local is within a local network. And unique local gets assigned automatically to the interface and to the nodes in the local network. This is the link local, right. It gets assigned automatically. By default, each node has a link local address and another address which is a global unicast address or something like this. But initially it has to have a link local address. Okay? The unique local does not get assigned automatically. So if you need to communicate using the unique local, the network planner will have to configure that. Okay? Within a network. And he or she also has to define the rules in the router, whether the router will have to pass it through or whether the router will have to block it. Okay? Of course, the default gateway of the entire organization has to block the IP address in that range. And it's not, as I said, it's not assigned automatically. Okay, so you have to do it manually if you want to use a unique local. And this is the closest category to private. But it's not, again, the difference between this and private is that this cannot be used with NAT. It does not get translated to public. Okay? So pay attention to the differences between the different types. Okay? So having said that, we need to go through the definitions first. So first we need to go through the definition and make sure that we can define these categories correctly, and then later on we'll talk about if you have a specific IP address, how can you categorize this address to one of these ranges. Okay, so the unique routable address, this is a global unique address. So IP address version 6 represented as colon 1, this is a loopback. It's represented as colon, this is a unspecified. And this is /64. And this is used to communicate with other devices on the same, this is a link loop. Okay, so I hope this one will be a little bit challenging.
It will be challenging.
So now we have to categorize these addresses and put it in a specific range. All right, so let's just discuss the ranges quickly. How many addresses are in this range? How many?
2:125.
Huh? I did not. Huh?
125.
Bravo, Ali. Yes. True. Correct. Yes. 2 to the power 125 addresses. And remember, we don't have broadcast addresses here, right? Which means that the host part is allowed to be all ones. Okay, remember that. Host part is allowed to be all ones. There's no broadcast. How many in this range? 180. Okay, so is there any overlap between this range and this range? That's a tricky question.
No, because this one starts from C and ends at D. This one is only at the FE. FE80 as well.
That's one thing. The other thing is this one /7, this one /10.
Yeah.
So when you put FC is actually 1111. This is F, and C is 1100. When you say /7, this means those 7 bits have to be common. Okay? So this one is FE, so 1111F, and E is 1110, and 8 is 1000, right? When you say /10, this means this 4 and this 4 and this 2. So there's clearly no overlap.
You know, if you actually have the actual bit, you know, representation.
It becomes easy, but you know,
Yeah.
so there's no overlap between the two ranges. Yeah. So the two ranges are isolated. So having said that, so what is this range? How can we categorize this address?
When? Where? What are you talking about?
This one. This.
Got too many? Okay.
لا خلاص okay, of course when we say /128, this is one single address, right? So we know that there's only one address in this range, so that's trivial. So now going back here, how can we categorize this address? 1 : 1.
Global.
Is it a loop back? No, it's not a loop back. It's not exactly global, right? Because it doesn't start with 2, right? So 1 here is actually 0001,
Yeah.
right? So it doesn't start with 2. So it's not exactly global. But actually, if you assign it in this range, the router will pass it through. But it's not a common practice to use it as a global unique address. And it's not a loopback address. I put it especially to trick you and confuse you with the loopback address. But it's not a loopback address. So this one is not applicable. It's not one of these ranges. This one in the exam, this one will be none of the above.
يعني انا نص ساعه ممكن كذا بس هو
Okay. What about FEA0? This is linked local. دي واضحة.
unspecified.
This one is unspecified. This is easy. FEBB.
Link local.
That's linked local.
And then global unicast.
And then let's see. Is this one global unicast?
لأنه 0 0 في الأول.
I omitted the leading zeros here. So 22 is actually 0022. Again, this one is here to trick you. مفهوم عليه؟ So it has to start with 2 or 3, by the way, because I told you here it's 2000/3, and 2 here is actually 0010, but it's /3. So those 3 bits are allowed to be common. The rest could be anything, which means that this one could be 1 as well. So if this one is 1, the 2 becomes a 3. So 3 is also global unicast. Okay? And this one is not applicable. It's not a global unicast. So at least I was able to challenge you a bit. Okay. So this one is a unique local, and this one is also unique local. Okay, so this one is easy. Okay, any questions? ايه ده ما خدناش الغير؟